Hello all, welcome to today's session of paper discussion chemistry part test 4. As you can see, the first question, all processes taking place in nature. So it's a second law statement that all natural processes are spontaneously occurring processes are irreversible, right? So all processes taking place in nature, that is nothing but natural process, they are spontaneously occurring. So nobody is aiding them. So naturally they are occurring and they are to be irreversible, right? So it's a straightforward theory-based question. Here, this question, I think it is corrected. So here it must be CO2 must be there. And even the data, everything data is for by 2. All the data which is given by 2 is the correct data. I'm sure you must have received the information. So if you go by these bond dissociation energies of these particular molecules, so then you are going to get, so CH4, and you have to balance it, please remember, plus 2O2 gives rise to CO2 plus 2H2O. So this is the balanced equation. So you are expressing in bond dissociation energy. So here you have to write the enthalpy of the reaction is to be written in terms of bond dissociation energy, the entire bond dissociation energy of the reactants minus the entire bond dissociation energy of the products. Correct? So I hope you all remember. So if it is for formation, it is product minus reactants. Otherwise, it is reactant. So in the reactant CH4, so there are CH4 contains 4 CH bonds. So 4 times CH bond dissociation energy plus, so 2O2 is there. So 2 into the bond dissociation energy of O double bond O. So 2 molecules are there. So this gives the entire bond dissociation of the reactants minus bond dissociation energy of the products. So in products CO2, so 2 times C double bond O is there plus H2O, again 2 times 2 H2O molecules. So in H2O there are 2 OH bonds, and those kind of H2Os 2 moles are there. So basically it is 4 moles of OH bond dissociation. So this is what we have to give. And here CH bond is 414 divided by 2. So it is basically 2 times of that. So 2 times 414, right? Plus, so this by 2 is this. So multiplied by this is 499. So this is the net one minus. So C double bond O, 2 times C double bond O is 745. So yeah, so directly you can write here 745 plus, 2 times OH is 464 because this by 2 is 1 OH. So 2 times OH is 464 and 4 times here. So 2 times multiplied by 464, right? So I suppose if you do this calculation, we shall get the correct answer definitely, which is minus 346 kilojoule. Okay, very good. So that's option D again. Yes. So next question, the bond dissociation energies of I2, Cl2, ICl are given respect to the enthalpy of sublimation of I2. So sublimation is basically I2 solid to I2 gas is the energy which you need to give, which is plus 62.8 kilojoule per mole. The standard enthalpy of formation of ICl. So ICl forms, standard enthalpy of formation means it should from the reference state. So the reference state of iodine is solid. So I2 solid plus Cl2 gas. That is, please remember, you have to keep half here because here when you are talking about formation, 1 mole must form from the reference state element. So this is the reaction. So for this reaction, we are planning to find. And the bond dissociation energies of I2Cl2 ICl is being mentioned. So why don't we, so the enthalpy of this particular reaction is nothing but the standard enthalpy of the formation of ICl, correct? Which can be expressed as 1 by 2 times the bond dissociation in of I and I solid, okay? So plus half into again bond dissociation energy of, okay, Cl and Cl gas minus bond dissociation energy of ICl. Okay, so this is what we are supposed to know. And now here, when you take about chlorine information is given here 242. So clearly it will go here. Iodine information is 141. This is for gas because bond dissociation energy is from I2 gas to 2I gas. So that is the definition. So you should be a little bit tricky here. So from I2 and again becoming 2I, this value is 151. Okay, to break this. And from I2 solid to I2 gas is 612. So the I2 solid to 2I will be naturally equal to 6 to 2.8 plus 151. This is the classic example of how we are going to use the, what shall I say, the Hess law. Okay, so I will explain again here. I2 solid to I2 gas is becoming 62.8, and I2 gas to 2I gas is what we understand as bond dissociation number to 151. So I2 solid to I2 gas will be this plus this, which is not written here. So, and I'm when I say bond dissociation energy of I2, so this is what we are planning to write here. So naturally, this is what we have to substitute. So the enthalpy of formation will be 1 by 2 times bond dissociation energy of I and I solid, right? So this is the bond dissociation. If it breaks, it converts to this. So which is 213.8 plus 1 by 2 times bond dissociation chlorine is given already 242.3 minus bond dissociation the ICL is 211.3. So I suppose if you are able to solve this, you will get the answer. Right? So here, I think we are getting here we exactly 16.75 kilojoule per mole. So 16.8, you can approximate it and get the answer. Right, very good. Next one, out of boiling point, intensive property. So intensive properties are properties which does not depend on mass. Clearly, you know, boiling point, whether you take 1 glass water or 1 liter water, the boiling point is same. So it is going to be intensive property. Entropy is a form of energy, so it cannot be intensive, it is extensive. pH value also, whether you take 1 liter sample or one big tank of sample, the pH of the solution will be same. So this is naturally intensive property. EMF voltage also is an intensive property. So the answer is 134, straightforward question. Similarly, lowest pKa. So the lowest pKa means we are expecting to be highest in acidic nature. So so when you have highest acidic nature, the pKa will be as low as possible. So here we are talking about the chlorine substituents of carboxylic acid. So C double bond OH. So here they are substituted. So the substituent, if it is a taking the electron density, naturally it will be taken, and this OH bond will also be taken, and this H plus releasing will become easier. So whoever are grabbing that is the minus I groups, which they are present more and more. So naturally the H plus releasing will be easier because the electron density of this OH bond is mostly shifted towards oxygen, and H plus can be easily broken. So as many, and it is an additive effect. So inductive effect, as many groups are there. So it's a clear cut answer. Isochoric process. Isochoric means nothing but, so constant volume process. So when there is a constant volume, so heat exchange at constant volume is nothing but change in internal energy. So the internal energy is equal to the heat exchange at constant process. So because you know the first law, Q plus W is equals to delta U, whether it is reversible or irreversible, this will be zero if the change in volume is not there. So heat exchange, the increase in internal energy is equal to the heat absorbed or evolved. Okay, so this is little tricky. So you have to understand whether heat is absorbed or evolved, because if you know, so we are talking about the increase in internal energy. So the increase in internal energy will happen only if you give energy to the system. So heat must be absorbed into the system, not evolved, right? So then only it is plus Q also, because you know the sign convention, anything you give to the system, it is positive. Anything you take, it is negative. So here it is clearly positive. So it has to be the absorbed heat. 2 moles of an ideal gas expanded isothermally, reversibly. This is the key. Isothermally and reversibly. And this is a physical 2 moles of an ideal gas. So it is a simple physical expansion compression. Okay. Physical expansion compression. These values are given for us to confuse us. So the enthalpy change they are asking, right? So first of all, the internal energy change, it is an isothermal reversible expansion. So the internal energy change is NCV delta T. So this is 0. And here, therefore, it is 0. And delta H is equals to NCP delta T. And again, it is 0. So the answer will be 0 down, undoubtedly. If it was a chemical reaction, then it was different. But here it is a simple expansion, compression, physical, the number of moles are not changing. So comfortably you can do like this, and straightforward answer 0. Observe the correct free expansion of gas under adiabatic condition. So adiabatic, whether it is reversible or irreversible, heat exchange is 0. And now the expanding against an external pressure is 0. So it is an irreversible expansion. Irreversible expansion. And it is free expansion. So the work done is in irreversible processes minus P external into delta V. The external pressure is 0. So the work done is also 0. And according to the first law of thermodynamics, if this and work are 0, then the change in internal energy must be 0. There is no other option. So it's a irreversible adiabatic case. Okay. So here the work done and the internal energy, the change in temperature, every term is becoming 0 here. So what shall be the answer? D. Yeah. Next question. The major product. So here we are simply do dehydration. Okay, so the H plus is going to attack on the OH, and H2O is lost, which results in a carbocation like this. So naturally it is a 1 degree carbocation. It will try to rearrange by a hydrogen shift. So there is a hydrogen here and there is a hydrogen here. So naturally it would prefer here. So it would go here and create a 3 degree carbocation, which is going to be more stable. And then after that you have the dehydration, that is removal of hydrogen. So the removal of hydrogen can happen here or as well as here, but naturally it would happen here because it will result in a more substitution. So that is a simple Kaiser rule. So for the given reaction A, here this is UV light bromination, so it will follow free radical substitution here. So this group CN has nothing to do with it. In the benzene ring also there cannot be, in these conditions there cannot be any kind of substitution. Substitution should happen here only in the outside molecule. So naturally the substitution will happen. So here this can be the cyanide here, right? And we are having so the methyl group. So here, if it happens here, it is a 1 degree carbocation. In here, it is free radical. Here is a 2 degree free radical. So naturally, at the 2 degree free radical, only bromination will happen. So this is also again a clear cut, straightforward question. The complete combustion of ethanol. So here ethanol liquid to O2. So this is a clearly balanced equation. So the amount of heat produced in bomb calorimeter is this. So as you must be aware, in the bomb calorimeter, whatever the heat measured is the change in internal energy, and heat produced it is. So you are supposed to use the sign convention. So minus 1364.47. This step is important. If you forget the sign convention at all, it's messed up. Okay, so please be clear. Assuming ideally the enthalpy of combustion of the reaction. So naturally, this is the combustion reaction. So for this reaction, they are asking you to find the delta H. So as we clearly see, the enthalpy change is delta U plus delta nRT. That is what we have to use because it is a chemical reaction. And the delta N is the change in number of gaseous moles. So here it is a liquid, so you can neglect this. Here 2 moles of gas, here 3 moles of gas is there. So delta N is minus 1. So minus 1364.47 minus 1 into R is 8.314 multiplied by temperature is 298. So again, approximated to 300. Please mind, I told you several times, I always tell you. So here, if you have kilojoules, this value will be in joules. So make sure that you multiply this by 1000 so that you will also get in kilojoule. So we have done this several times. So I'm sure you teachers would have also pointed at this particular thing. So 20, so if you write 8.314 as 25 by 3, so this gets cancelled. So 25 by 3, the 3 is cancelled and 2 zeros are gone. So it will be 2.5. So minus 1364.47 minus 2.5. Then both are in same units, kilojoule per mole. So absolutely it makes sense to, simply add it up. So it is minus 136695. Yeah, this could be the answer. Okay, correct order of stability of the carbocation. So you see everywhere there is unsaturation is there. So except this one. So on an unsaturation, if negative bond is there, then it is negative charge can be better, but better held. Okay, so because unsaturated carbons will be either sp or sp2 hybridized, they are more electronegative, so they prefer to take the electron density on themselves and they'll be more stable. So if you are keeping a cation, then naturally it is causing some kind of instability. So the first most stable will be the obvious one, the benzyl carbocation. So this one is obviously most stable because of resonating structures. Resonance is there. So this will be the highest one. A is highest. So actually, it's a very simple question. You need not know the rest of the things. You know A is correct answer, it is done. So naturally, as I told you, so here it is sp3 hybridized, here it is sp2 hybridized, sp hybridized. If it was negative charge, then it would have been the other way around. But it is positive charge, so it is CBD. So clear cut, it's a straightforward question. Even this also, you are testing you the basics only. 5 moles of gas put through series of changes in the cyclic process. A to B. So A to B in this case, volume is constant. So it is isochoric, right? So option A or D can be correct. Now B to C, volume is proportional to temperature. So clearly pressure is constant. So it has to be isobaric. Then C to A, if you go by, then temperature is constant. So it is isothermal. So that's again straightforward answer. Bond dissociation enthalpies of so and so are given. What is the heat of hydrogenation of ethylene? So when you talk about heat of hydrogenation with the help of bond dissociation, you're supposed to write the equation first clearly, and then once you maintain the equation, then rest all will follow. So ethylene is nothing but C2H4, so C double bond C, and hydrogens are present, and you are going to do hydration. So it will convert into C2H6. So ethane is produced. So they are asking for this process, what is the enthalpy of the reaction? Because this reaction is only nothing but heat of hydrogenation. So you hydrogenate this one. So in this case, what is the bond dissociation? So you want to write in terms of bond dissociation enthalpy. So every time you have to write again, remember, bond dissociation is the reactant minus product. So how many bonds are there in this particular case? So there are 4 CH bonds plus 1 C double bond C. That will be the bond dissociation of this molecule plus bond dissociation energy of H and H minus C2H6 has this structure, as you all must be aware. So it will have 6 CH bonds and 1 C single bond C. Correct. So that will be the answer for this particular question. So you just need to substitute. So CH bonds is 410. So 4 times 410 here plus C double bond C is, be careful with the data. If you copy it wrong, everything will go away. So hydrogen data is the third one. So 400 minus 6 times CH. So I will remove the bracket actually. 6 times into 410. Okay. Plus 1 times CC. So CC is 360. Okay. So I'm sure if you do this, you should be getting the answer, no doubt in that. So 600, 400 is 1000. Okay. So 410 and this is minus of this. So 2 times 410. So 820 and this is minus 360. Right. So this is 1180 minus this. So minus 180. Minus 180. So this will be the answer. Strongest acid. So these are all phenols. So we all know that phenol is acidic because the phenoxide ion which is formed is resonance stabilized, right? So that is why it is being acidic. So the acidic groups are attached with these groups which are minus I plus I groups. So naturally the acidic nature, as we have discussed earlier, will be affected better if the nearest group all are in meta position. So you need not worry about the ortho effect also. All are in meta position. So straightforward question. So whichever is able to produce the minus A effect in an effective, the best possible manner will make the groups acidic. Which of the following shows highest dipole moment? So dipole, so all these type of molecules, there is a C double bond C attached in the middle of two molecules. So here you just need to, which creates more polarities is what you need to check. So if this double bond, splits into like this by creating the polarity. So as we all know, dipole moment will depend on bond dissociation. Sorry, not bond dissociation, bond distance and charge. So dipole moment delta is proportional, sorry, mu is proportional to delta multiplied by distance. We are not, so everywhere we are comparing about the C double bond C only. So the distance more or less is going to be same, except in this case. So this is not the main factor. The main factor will be the charge. So whoever gets more charge separation will be the perfect answer. So suppose if you imagine here a plus and a minus here, why would it do it? So this will be aromatic ring, but this will not be aromatic. So this will not be ready to break it into plus and minus. But if you look at this particular case, it's a clear and obvious molecule. So where if it breaks into plus like this, and if it breaks into minus like this, so this will be an aromatic, this will be aromatic ring, and this is also an aromatic ring. So naturally, this molecule will be very much inclined to break it into plus and minus like this, which creates the maximum charge difference, and that is why it has the highest dipole moment. So here C double bond says that's only because of the electronegativity. Sorry, that's only because of the electronegativity difference we are going to have minus and plus. Apart from this, there is no other factor. So here also there is, of course, they can break, but there is no aromaticity coming into both the rings, separate systems. But here, as I told you, so this will give you a massive advantage. So that is why this molecule is always ready, willing to split into two types. I'm sure this kind of one also we have discussed. Consider the following species: the compound species obeying Huckel's rule. So Huckel's rule is nothing but the first molecule, the molecule must be planar. Second case, it should have a conjugated system. And third one is the law 4n plus 2 pi electrons. So I'm sure all these molecules are planar molecules because I mean maybe this one, yeah, everything is planar. So everywhere you are having sp2 hydrocarbons. So and conjugated systems, I think everywhere there are conjugated systems as well. So the first two conditions are met every time. So the only thing which we need to check is the 4n plus 2 pi electrons. So in whichever case the 4n plus 2 pi electrons are there, I think here we can go for it. So this molecule is clearly the correct answer because this ring and this ring, if you individually check, 6 and 6 are there, no problem. Here again, this one also 1, 2, 3, 4, 5, 6, 6 pi electrons are there. So this is also a correct option. And here only 4 pi electrons are there. So this is not a correct option. And if it was a positive charge, here also 4 pi electrons are there. So this is also not a correct option. This one is a 2 pi electrons are there, which were again raised to a correct option. So, and this one again, 8 pi electrons are there. So not a correct option. And this one again, each and every ring is having 6. So this is also a correct option. So 4 options. So 4 numbers are obeying the Huckel's. The enthalpy change for decomposition of 1 mole of water. So 1 mole of water has to decompose. So this is what they are asking, expecting you to find. For this, they have given for this, they are asking for this straightforward question. Decomposition, not dissociation. If it is dissociation, then it would dissociate into H plus and OH minus. Then this data will be not be enough. But here we are talking about decomposition only. So water is decomposing into hydrogen and oxygen. So clear cut answer. So you just need to reverse it and divide it by half. You are going to get the answer, right? So true. So we are going to reverse it. So minus 483, we are going to reverse it as plus 483 and then divide it by 2. So 483.64 divided by 2. So it shall come under 241 something. Yeah, so you are getting this answer. The only thing probably you could argue is it should have been liquid because they are asking for water. Yeah, but when you are talking about decomposition, so yeah, so naturally that heating will make it liquid. So here, if it was been liquid, then the option would have been better actually. Question. But fine, we are given the data, so we shall go by that data. Otherwise, enthalpy of vaporization should have been provided. Then only it makes more sense. Fine, with that given data, that should be the answer, right? So the species having carbon with 6 set electrons. So 6 means carbon is supposed to have 8, but it's only having 6. So definitely it is a electron deficient molecules. Electron deficient molecules are generally electrophiles because they have less. So the carbon is having an empty case where it can accept. So they are electron loving, so electrophils. The electrophils are carbocations. Okay, so by the given option, clear. The boiling point of three isomeric pentanes are N-pentane, isopentane, neopentane. I think this is correct because boiling point is proportional to the surface area. So as branches increases, the molecules attains the shape of sphere. This results in smaller surface area contact, due to which intermolecular force between the are weak, thereby lowering. Absolutely correct. On dot explanation. So this is the correct reason, and this is the perfect explanation also. Okay, so I don't think I need to explain anything else here. So this has a more surface area than this particular case, right? So that is why the van der Waals forces will be more when the surface area is more, which we have, that's what we have discussed. Okay. In the case of melting point, you have to be a little bit careful. Number of acidic hydrogens. So acidic hydrogens is nothing but the C double bond O is there. So the alpha carbons associated will be acidic. So for this is the alpha hydrogen. So definitely acidic. This is more acidic. This is also very acidic. And this is nitrogen lone pair is there. So if it loses its H plus, it becomes minus. Ready to take electrons from it. So this also are two acidic. Generally, they are loose bases. So they are 5 protons are there. Okay, so the number of acidic hydrogens will be 5. The number of correct statements involving equilibrium in physical process, physical equilibrium, that is nothing but phase transfers, right? Phase transfers are what we call it as physical equilibrium. So equilibrium is possible only in a closed vessel, so which is absolutely correct. Suppose H2O liquid is there, and if you leave it in the open vessel, the H2O gas, everything will evaporate and escape out. So what is the point? Okay, so it will be there only in a closed vessel. That's both the opposing process, that is forward as well as backward, occur at the same rate. So that is the basic definition of equilibrium. That is correct. When equilibrium is attained at a given temperature, the value of its parameters become equal. The rate becomes equal, not the parameters. The parameters will become constant. So that is how the equilibrium constant will be maintained. So the Q, which is variable till then, will become constant. Okay, so Q becomes K. So they need not be equal. If they are equal, always the equilibrium constant will be 1, right? So that's not the case. So they will be changing. They will attain a constant. The ratio will become constant. For dissolution of solids in liquid, the solubility is constant at a given temperature. That's fixed. Because solid and liquid will not be part of equilibrium constant. So no matter whatever add or substitute you do for solid and liquid, it doesn't change. HBr major product, number of hyperconjugate structures involved to stabilize carbocation formed in the above reaction. So first of all, what is the carbocation formed? So HBr is gone. So here you can think of something like this, right? So here there is a methyl group, and here it is this one, because H plus H2O it's lost. So this carbocation which is formed can have how many alpha hydrogens? So 1, 2, 1, 2 over here, and 1, 2, 3, 4, then nothing. So only 2. So yeah, this is the case, 2 are the case. But if there is a methyl shift, let's say there is a methyl shift like this. Sorry. Yeah, there is a methyl shift like this. Then here, if there is a methyl group coming here, and if there is a positive group over here, which results in a 3-degree carbocation, which makes more sense. Suppose if it is like this, then 1, 2, then here 1, 2, 3, and then here 4. Right, so just 4. And including this structure, it will be 5. So 5. So this is definitely better than this. So is there any other possibility we have to have? Okay, so let's say the methyl group is shifted here. And here, yeah, this is also a 3-degree carbocation, right? So plus here and a methyl group over here. That is obtained by the hydrogen shift, which is present here. Okay, so from here, if there is a hydrogen shift here, then they will get. So then the methyl group has itself 3 alpha hydrogens, and there is another hydrogen and another hydrogen. Yeah. So 1, 2, 3, 4, 5, 6, and this structure itself. So 7 structures we are getting. So 7 positives. So these are definitely more than this. I don't think anywhere else it is possible. This is happening because the carbocation, the positive charge is present where the methyl group is there. So I think that's the reason why the answer is item also given to this 7. So again, the same question, more or less repeated. Intensive, volume is extensive, definitely depend on space, amount. So molar heat capacity is extensive, but molar heat capacity will be intensive, correct? Molarity, concentration terms, all concentration terms are intensive properties. E naught cell intensive, change in Gibbs free energy, any form of energy. Okay, if it is not molar or specific energies, otherwise any forms of energies are Gibbs free energy. So any form of energy is a extensive property. So this is not, this is extensive. Molar mass independent of the amount of substance you take. So this is also there. Number of moles, obviously it is depends on the amount. So this is definitely extensive. Molar mass is extensive. So we are having 1, 2, 3, 4, 4 number of 4 are there. Correct. Certain thermochemical reaction temperature enthalpies are given. The equilibrium constant log K. So I'm sure that delta G naught, which is delta H naught minus T delta S naught. So delta G naught is minus RT ln K. So this is the formula we have from electrochemistry and chemical equilibrium and thermodynamics, all the things together. So this is minus 2.303 RT log K. Okay. So which will be delta H naught minus T delta S naught. So this involves a big calculation. 77.2, this is given in kilojoules. So I would multiply this by 1000. Yes, because it's better to keep it in joules. Minus temperature is 400. Entropy is 122. So this value comes to be, I think all of you must have calculated it. So it involves a little bit bigger calculation. So this is into 1000. So 77200 minus 48800. So excuse me, I'm sorry. So now this one will be 28400. This is the enthalpy in joules you got. So this is no minus, there is no minus here. So here we are having minus 2.303 nRT. So 25 by 3 into temperature is 400 into log K. So I'm sure all of you must take little time to calculate. I'm writing the direct value. Log K is minus 3.7 approximately. And the question is only log K. So actually there is no anti-logarithm required. So log K is only asked. So it is minus 337 into 10 power minus 1. So 37 shall be the answer. Thank you guys. I hope you all understood every question. Thank you very much.